Huh? Yeah, whatever you do to the top, you have to do it to the bottom. Otherwise, you're changing the problem. All right? Right. Right. So on the top, I have a plus h minus a, right? Because you just take the squares of both. Bottom, I know you have this urge to distribute that h, but don't do that because something beautiful will happen right now. Okay, so what happens to the numerator? What do you have? H over this, right? And then what happens to the h's? They go away. And so you have 1 over the square root of a plus h plus root a. And so that's it. This is where we're going to stop. And you might think that we're worse off than where we started because now we still have roots, but now they're in the denominator, which we always have known that that was illegal. But for the purposes of why we're doing this, the purpose of why we were doing this was to get rid of the h in the denominator, which now we have done that. And you'll see in chapter 12 why that's useful. Okay? Limits. All right, here we go. Here's the biggie. We need to solve for x, right? So here is x right here. And then let's see what we have on the opposite side. We have ln of e plus 1. What is that? Variable, constant, what? But what's ln of e plus 1? Is it a variable or a constant? Is it a number or a variable? It's a constant. What about ln of 1? Constant over e? Constant. So constant minus constant divided by constant. This whole thing is just a constant. It's just a number. It may have been like, 3.782. We just wrote it like this in this more complicated form. So we have 1 over x plus 1 equals to that constant. Okay, the point now is, how do we solve it? Ideas. What am I supposed to do? I have cross multiply. Any other ideas? That's like, right, and then you would have to multiply both sides by that, right? So that's like, yeah, okay. None of those sound very fun to me. They're mathematically sound and correct. Can't do that. Here's what I'm going to do, though. Okay, so way back when, years ago, in geometry, when you learned about proportions, and before that in algebra, when you learned about proportions, you learned that if you have 4 over x equal to, let's say, 3 over 5, this is equivalent to x over 4 equal to 5 over 3. You can take a proportion and flip both sides, and it's the same because it doesn't matter if you're looking at it top down or bottom up, right? So here, I can flip this. Right, so here we get e over ln of e plus 1 minus ln of 1. And x plus 1 over 1, that's silly. That's just x plus 1. And then what can I do to solve this? Just subtract the 1. Nope, not at all. It would have been had we cross multiplied. Okay? So you can do this every single time. When you have a proportion, flip it. Now, can you do that if you had this? No. Right, once you add them though, and you have 1 ratio and 1 ratio, then you could. But you can't do it here. Fantastic. Alrighty. Factoring. We've touched on this. You can't get enough though. What can I factor out of these?
An x.
Not an x.
A negative.
A 1 plus 2x.
Just a 1 plus 2x?
To the power of negative.
To the power of.
Oh, yeah,
To to the power of negative 3 over 2 because that's the smaller, lesser exponent. So 1 plus 2x to the power of negative 3 over 2. And now, do you remember when we talked about, like, if you have x to the 4 plus x squared, and I factor out an x squared, that's like dividing by x squared, right? So when we're factoring out, this is like dividing by this. So from the leftmost term, what do I have left? Just negative x plus, here I have 1 plus 2x to the power of what? What happens to the x to the 4 divided by x squared? What do I do to the exponent? Subtract them. Top minus bottom. Top, negative 1/2, minus bottom is plus 3 over 2. So how much is that? That's just 1. Because negative half plus 1.5 is 1. So y equals 1 plus 2x to the negative 3 over 2. Negative x plus 1 plus 2x. Right. So this is 1 plus 2x to the negative 3 over 2. And here I have x plus 1. Right? Or 1 plus x. Right? We're writing this stuff down? I know. Then just listen and don't talk. But, you know, do write these down. Okay? All right. Okay, so here, what are we going to do? Divide by what? Factor out of what? X cubed plus 1 to the negative 1/2. So here I have x cubed. This goes away, right? From here. And then plus x cubed plus 1 to the power of how much? Negative 1 or positive 1? Positive 1. Because it's going to be 1/2 minus negative 1/2 plus 1. So it's positive 1. Right? So that means y equals x cubed plus 1 to the negative 1/2. Now, I can get rid of these parentheses. So I have 1.5 x cubed plus another 1x cubed. So that's 5 over 2x cubed plus 1. Okay, one thing I forgot to do because I was distracted here is we're not allowed to have negative exponents. So the top one here, it's got to be x plus 1 over 1 plus 2x to the 3 over 2. Okay? Or x plus 1 square root of 1 plus 2x cubed.
So if I like the first way you did it better, can I do that? Can I just do it with positive exponent, not the square root?
Okay, so the thing is, we have to step away from, can I do this or can I do that? Because the big picture is, you should know that those two are equivalent and that they're interchangeable. Because if this was a multiple choice question, then the answer could be given to you in both ways. And going back and forth should be like a reflex at this point. All right? Not something that you have to think about. Okay. Next one. Same situation. This is 5 over 2x cubed plus 1 over the square root of x cubed plus 1. Okay? Another way to write it is, if you don't like the 5 over 2 over there, multiply both by 2, and then you get 5x cubed plus 2 over 2x cubed plus 1. Again, you don't know what format the answer to the multiple choice will be in. All right? And you just have to recognize them like instinctively and say they're the same. All right.